today we are talking about rational functions or rational expressions, okay? So basically our common core standard is going to be rational expressions. And what we want to do eventually is add, subtract, multiply, and divide, okay? But today we're just going to talk about multiply and divide, okay? Because those are the easy ones, really. When you add and subtract, we're going to have to get a common denominator. And we'll talk about that tomorrow. But for today, so if we have to define a rational function, all it is just a fraction, okay? But we're going to be a little bit more specific about it. It's going to be a fraction with x's and y's. So it's going to have x or y or variable terms as a fraction, okay? An example could be something like an x squared minus 9 over, say, an x plus 3. That's a rational expression, okay? It's a fraction. It has x's in it, okay? And then we'll take a look at this later and we'll simplify it. So that's a rational expression. It's just a fraction with x's in it, okay? Now, the way we're going to multiply or divide is the following. The very first step we should always do is factor, if you can. Step one is to factor, and that's if you can, because not everything can be factored. If you can factor it, you want to factor, okay? Then the second thing we want to do is we want to go back to what Michaela said earlier when we were taking a look on these. The second thing we do is we're going to try and cross-simplify next, all right? So step 2 would be to cross-simplify. And then she said cross-simplify, which we did, and then we multiplied straight across, didn't we? Okay, and we're going to do the same thing with these. So in step 3, we're going to multiply straight across. And then finally, step 4 is we're just going to simplify our answer. That's all we're going to do. So I'm going to take this, we're going to do several problems. You guys are going to see how we do this. So step 4 is just to simplify the answer. Alright, now example 5b, we're going to actually look at it, but I want to show you what example 5b is. So if you go to page 577, let's take a look at it. 577, I'm getting there. Let's just show you something. Alright, actually go to 579, okay? So here's what I want to show you, more than anything, is this piece right here. In fact, I'll highlight it, okay? So we're going to learn how to do this, but one of the things they put is this note right here, okay? And they note that x cannot equal negative 1, okay? I'm going to write that down. Okay, you're not on your phone, of course you're not. So they have this expression, x squared plus 3x minus 4 over x minus 1. And they say, note, x cannot equal 1. Yeah. Okay, so yesterday, in fact, we even did it on the cell phone, remember? We said, okay, what's 0 divided by 0? And our phone went on to talk about how, you know, if you have no cookies and no friends, it doesn't make any sense, because then Cookie Monster has no friends and Cookie Monster has no cookies. It's very sad. So one of the things we cannot do is we cannot divide by 0. So we're going to simplify this problem, but they make the side note over here for a very good reason. Because if x were 1, if I were to take the value of 1 and plug it in for x, I'd have 1 minus 1. And 1 minus 1 is 0, but you cannot divide by 0. In fact, if you try it on a calculator, if you want anything divided by 0, you're going to get an error, right? We tried that yesterday and it didn't work. In fact, if I can find a calculator, I'll put it in there for you. But oh no, of course I don't have a calculator. Of course I don't have a calculator. No. Okay, hold on. I know I'm recording, but you know. Here's my calculator. So we looked at it yesterday that if you take and go anything divided by 0, you get this weird, it says divide by 0. Can't do that, okay? It's not real. Okay, so we're going to quit. So, when we know that, when we go through our problems today, if we get anything that makes us divide by 0, we cannot count that answer. So in this case, no matter what we do, x cannot equal 1, okay? Alright, let's take a look at the notes for today. So that's my reading. So our notes today You're going to have a whole bunch of problems like that, okay? So, first few examples are pretty easy, okay? So, before I even do example 1, one of the things I want to make sure is I write down our exceptions, okay? The exceptions. So, what can x not be? Meaning x cannot be something, okay? Question mark, question mark, question mark, okay? So before I even do this problem, right off the bat, if x were 0, you'd be divided by 0. So before I even do this problem, I'm going to make this little statement, a little side note. Remember how I did the note? X cannot equal 0. Because if x is 0, you can divide by 0. It can't happen. Now, simplifying this was pretty easy. This is like an algebra 1 problem. You know it's going to be a fraction, so I make my little fraction bar. I'm going to reduce 3, 6 reduces to 1/2. 4 of these x's will cancel with 4 of these x's. 4 are gone, then there's 3 left over on the top. So my answer would just reduce to 1/2 x cubed. That's it. We have our restriction in the beginning. The restriction isn't the answer. It just is a restriction saying no matter what, don't let x equal 0, okay? Let's do example 2. Okay, first of all, my restriction, my exception. Okay, first of all, x cannot equal 0 because I would divide by 0. And y can't equal 0 either, because if y equals 0, I'd be divided by 0. So I have to put in my restrictions. Okay, one of the things we know before you do anything is say, okay, what is going to make this thing divide by 0? What's going to make Cookie Monster unhappy? If you divide by 0, don't let x equal 0. Don't let y equal 0. Now let's just solve it. Okay, fraction line, right? 6 divided by 3 is 2. 3 of these x's cancel 3 of these x's, so I'm left with x to the 4th on the bottom. 3 of these y's cancel 3 of these y's, so I'm left with y to the 2nd on top. That's it. It's pretty easy. Example 3. There's 2 ways to example 3. I think the easiest way to do it is I'm going to cancel. I'm going to cross simplify like Michaela suggested, the big numbers, and then I'll probably multiply through and then cancel the x's. So I think the first thing I'm going to do is take a look and possibly cancel 3 and 15, right? I'll make that a 1 and a 5. Cancel my 2 and my 8. I'll make that a 1 and a 4, okay? So I just cross-simplified my numbers. 2 8s and 15 thirds. So let me go ahead now and multiply straight across. So I'd get a 5 on top. I'd have an x to the 6th. Y to the 5th. Okay, I'm just multiplying straight across. X to the 6th, y to the 5th over, I'll have an x to the 5th over a y squared. Okay, now it gets pretty easy because I'm just going to cancel x's with x's and y's with y's. I can do that. So again, it's going to be a fraction. I know the 5, oh, I forgot the 4 too. Forgot the 4. 5 fourths. 5 of these x's will cancel 5 of these x's, so I'm left with just 1x on the top. 2 of these y's cancel 2 of these y's, so I'm left with y to the 3rd on the top, okay? As far as restrictions, what x can and cannot be, again, originally, x cannot equal 0 and y cannot equal 0. Because if they are equal to 0, you'll divide by 0, okay? Yeah, Grace? You got it? Okay. Example 4, we're going to divide, right? So if we're going to divide, let's flip the second fraction, not the first, the second, okay? So we're going to flip the second, so we're going to flip this one, and we're going to change it to multiplication, okay? So let's rewrite it. So 4x cubed over 9x squared times, if I flip it, 9y to the 5th over 16, okay? So once I flip it, then we can say for sure that x cannot equal 0, because if x is 0, we're in trouble. But y is okay, because now y is in the top, right? So 0 on the top, or the numerator, is okay, but 0 on the bottom, or the denominator is bad. Okay, let's just simplify. Now, first of all, looks to me as if I can cancel some 9s. 9 cancels with 9, right? I can cancel the 4 and the 16. 1 and 4, right? And I think I can then cancel some x's too. So let's see what I got for an answer. Fraction bar. Looks like the 4 is on the bottom, right? X cubed, x squared. So 2 of these x's will cancel with 2 of these x's. So I'll just be left with an x on the top. And then y to the 5th, there's no other y, so I'm just left with my y to the 5th. Alright, example 5 is totally different. Example 5 is totally different. Do not cancel the x squareds. Do not. In fact, I want to show you something on the side of why I can convince you not to cancel the x squareds. Okay, let's take something as simple as this fraction. If I have 7 plus 2 divided by 2, okay? So, if I don't know any better, really, if I don't know any better, I cancel the 2 and the answer is 7, right? Isn't the answer just 7? Cancel the 2s, isn't the answer 7? No way. You can't cancel those 2s because the answer is really 9 over 2, which is 4.5, right? So you cannot cancel this way because you need to take the entire top to be divided by 2. So if we come back to example 5, don't cancel the x squareds. What you have to do instead is factor, okay? You're going to have to factor. So if I factor the top or the numerator, I'll get an x minus 3, x plus 1. I want the multiples of negative 3, that add up to negative 2. In the denominator, I'm going to factor it into a x plus 1 and an x plus 4, okay? Okay, before I finish it, because it's pretty easy, you guys are going to see the cancellation, but before I finish it, I'm going to look at my exceptions. I'm going to say that x cannot equal negative 1, because if that was negative 1, we divide by 0, and x cannot equal negative 4, because if that was negative 4 plus 4, you get 0, okay? Now let's finish it up. Let's get the answer, okay? X plus 1 cancels with x plus 1, right? What I'm left with then is x minus 3 over x plus 4, and that's your answer. Don't cancel the x's. Don't cancel the x's, okay? Okay, example 6 is really close to the same thing, but there's a little problem with example 6, but we'll figure it out. So let's factor, okay? Let's factor again. So if I factor, I'm going to factor it over here. Take out a common 2x. No, just common x. I'm sorry. Common x. I'll be left with, that's pretty sloppy, x. I'll be left with a 2 minus x. And on the bottom, I'm going to factor it into an x minus 2, x plus 1. Boy, I'd really like to cancel these, but they're not the same. But I'm going to do a little trick. Yep. If I factor out a negative 1, if I factor out a negative 1, it'll turn this around into a positive x and a negative 2. So I'm going to factor out also a negative 1. So let me rewrite this. I'm going to bring out a negative 1 with the x, and what happens when I take out the negative 1, the negative comes out of the x and becomes an x. The negative comes out of the 2, makes it a negative 2, okay? So when I factored out the negative 1, it changed its sign and turned around, okay? Then I'd have my x minus 2, my x plus 1, okay? My exceptions, x cannot equal 2 and x cannot equal negative 1, okay? Again, those are not part of the answer, but we need to know what you can't have because you can't divide by 0. Okay, now we can finish it up, right? That'll cancel with that. And what we're left with is a negative 1x over an x plus 1. That's my answer. So you got to be able to factor, right? Okay, 7. 7 is just a bigger version of what we've been doing. If we can factor, we can get it. So if I factor this one out of 3, I'll be left with an x plus 4, right? I can factor this into an x plus 2, x minus 2, right? All over this. And then what I know as far as, before I cancel, exceptions, x cannot equal negative 4. Can't be negative 4, because if it's negative 4, I would divide by 0. X cannot equal negative 2, because negative 2 plus 2 is 0. X cannot equal 2, because 2 minus 2 would be 0. But I'm not done. Let's finish this up. So I have an x plus 2 on the top. Cancel that x plus 2, right? I have an x plus 4 on the top. Cancel out that. Okay, so what's my answer? Let's see, there's nothing left on top. I got to have something on top. My answer is a fraction, but there's nothing on top. What do I put on the top to make sure it's a fraction? A 1, right? So I'll put a 1 over. What's left on the bottom is the 3 and the x minus 2. So I'm just going to go 3 and the x minus 2, okay? All right, example 8. Oh, I got to divide, right? So divide, let's rewrite it, and let's flip this one. We're going to flip this one, okay? So let me rewrite it. x5 minus 4x cubed over x squared minus x minus 2. Okay, that's the first fraction, right? We're going to flip the second fraction. We're going to flip it. So the x squared minus 1 goes on top in the numerator, and the x to the 5th minus x to the 4th minus 2x cubed, it flips down to the denominator. x5 minus x4 minus 2x cubed. Okay, now we got to factor. This is kind of a hard problem, but I can do it. Let's factor, okay? So right at the bat, let's factor the top. Okay, I'm going to have to squeeze this stuff down here, but these two have a common x cubed. I can take out an x cubed. You see that? They both have at least an x cubed in common. So I take out the x cubed. If I take out an x cubed, I have an x squared minus 4. Okay? In the bottom here, that'll factor into x minus 2, x plus 1, right? This will factor into an x plus 1, x minus 1. And in the bottom, they have a common x cubed. Okay, so I can common factor and add an x cubed because they all have at least 3 x's in common. Oh, let's see, x squared minus 1x minus 2. Okay. All right, I can cancel. I can definitely cancel this x cubed. So I can take out this x cubed, cancel it, x cubed for x cubed. But there's more. There's more to do because this x squared minus 4, it can be factored again, can't it? All right, so this is going to be a big problem, but I think we can do it. Okay, I'm going to take and put this answer, I'm going to start squeezing the answer over here. So this factors into an x plus 2, x minus 2, okay? That does x squared minus 4. On the bottom, you've got the x minus 2, x plus 1, right? Times, well, we've got my, oh, I'm really squeezing this in here, aren't I? X plus 1, sorry, it's so squished in, x minus 1. And this can be factored into an x minus 2 times an x plus 1. Now, can we cancel? Heck yeah. Cancel away. X minus 2 with x minus 2, okay? Have an x plus 1 with an x plus 1, okay? Can I cancel anything else? I don't think so, can I? I don't think so. So, my grand answer, this is a big one, is going to be an x plus 2 x minus 1 over an x minus 2 and an x plus 1. Okay, now, what are the values in this above expression that are undefined? So let's go back to it. What x cannot be, ready? X cannot be 2. Right here, x cannot be 2, right? If x is 2, we divide by 0. So x cannot equal 2. Let's see what else. X cannot equal negative 1 right here, because negative 1 plus 1 would make us divide by 0. X cannot be 2, we knew that one. X equals negative 1. And finally, x cannot be 0, because way up here we would have had a 0, okay? And x cannot equal 0. Alright, this is usually a hard unit. But we're going to do our best to get it, right? Okay, when we flip the page, they're a little easier. In fact, this was probably the hardest one. You ready to turn the page? Yeah. Am I going too fast? I'm okay? Okay. We'll do some more of these. I'll help you with your homework, okay? These are hard, but I'll help you with your homework. Okay. Okay, we'll work on the homework together. Okay. You good? Okay, turn the page. Now, example 8. Okay, now, listen carefully. To do example 8, there's 2 ways, okay? Obviously the hard way and then the easy way. Now the hard way would be this. Cross multiply, right? Solve, but you'd have an x squared. Or the easy way is, hey, what if we could factor first? Would that help me out? Could I factor x squared minus 9? What's that factor into?
X minus 3.
And that's over an x plus 3, isn't it? Okay. Hey, I see something, don't you? What do you see? They cancel out. So what am I left with? I'm left with x minus 3 equals 7. Hey, that's pretty easy to solve for, right? Plus 3, x equals 10. One thing for sure, x way up here, x could not equal negative 3. In fact, if I got an answer down here of negative 3, guess what I'd have to do? I'd have to say no solution. Okay?
Is that it? If it says that, or you can...
I know for sure if x were negative 3, I'd be in trouble, right? Why would it be in trouble if x equals negative 3? Negative 3 would make me divide by 0, right? That'd make Cookie Monster unhappy. Let's take a look at example 9. Okay?
That one's easy.
Can you factor? Sure. So let's factor. So what does it factor into? Okay, what do you think? So I'm really left with x plus 4 equals 5, right? Minus 4, x equals 1, right? No! X does not equal 1. X can't equal 1. Why not?
Wait, but isn't it x plus 4 is 5? Oh, wait. Because this is negative 5.
So, I mean, everything makes sense, but if I were to put the 1 right back here, if I put the 1 right back here, what's going to happen? Yes. So we have no answer, right? So there's got to be no solution. Because if x equals 0, you will divide by 0. Because if you take the 1 and plug it back right into there, you have 1 minus 1 is 0. So no solution. All right.